Hi everybody, I'd like to do a video around the LOLIN S3 Mini Pro. This is a small development board with the ESP32S3 on it and a 0.85 inch display. It's a nice little nifty board and it just came out last month and it's currently $7 on AliExpress. So mine just arrived recently, but the one downside, and there's a few comments on this news post as well, that there isn't much documentation. The other downside is when you first plug in the board, as I'll demonstrate, it doesn't really do much. So I'd like to show how you can connect to the board. Currently it runs MicroPython by default, that's flash from the factory, and how to get the LED to show up. I'm on Linux, so I'm going to use Minicom to connect to the device, but if you're on Windows you can use PuTTY. So for me it's Minicom dev/ttyacm0. Give it a second, it should connect. And then if you do Control D, this will cause the device to restart. And you can see it's running MicroPython version 1.23, and it's the LOLIN S3 Mini Pro. We'll talk a little bit later on more about this hash and where it comes from. So first we need to import S3 Mini Pro. Then we need to, from machine, import pin. Then we need to set up one of the power pins. So it's pin S3 Mini Pro. Oh, and you can do tab complete as well, which is nice and handy. Power. We set that pin to be output and the value to be equal to 1. Okay. Now in this S3 Mini Pro module, there's a RGB LED command, and we just put in the 3 values. So I'm going to do green, so 0 for red, 255 for green, and 0 for the blue. And ta-da, we have an LED going. Right, so next I just want to talk a little bit around the information that I did find. So from this page it links across to the WeMOS page, which has the overview of the board and also the other boards that they make. So they also have the Pro and the S3. This has a good handy link to the schematic and a nice little diagram. The next bit I wanted to talk about was MicroPython. So it doesn't talk too much about MicroPython. It has this getting started page, but that really just mentions how to flash the board with it. So if you go to the MicroPython official repo and you look at the boards, it has the C3 Mini and a few others, but it doesn't have this Mini Pro. That board information is actually part of a fork by WeMOS, and in there they actually have the S3 Mini Pro down here. Next up, if you go to the releases tab in that same repo, this is the latest one that came out July 11th. So this is the first one that has the S3 Mini Pro binary that comes out, and that hash is the same one that's currently flashed. So at the time of recording, that's where that version is coming from. Next up, one of the particular files within that boards directory, it has this test file. So this has useful information around how to potentially interact with some of the peripherals. I mainly just interact with the RGB LED at the moment, but I plan to see what else I can get going soon. And so next up, the schematic. So the reason why we had to turn on that power pin is this is the LED, and you can see the VDD is connected to pin 7, and then pin 8 connects to the actual control of it. And this is the S3 Mini Pro module, so similar thing. The power is at 7, and then the data is connects to that IO 8, but it's all nicely handled by this RGB LED function that we called, which sets up the NeoPixel. I'd also like to talk about this PyBoard tool, which is part of MicroPython. So obviously you wouldn't want to write every single command all the time if you want to run something. So we handy to have a script and then just send that script to the device. And so if I exit out and reboot the board, you'll notice that on boot up it's gone back to how it was before. So if I bring up VS Code, I've written the same lines that we wrote in a script form, and if I just download this MicroPython tool, just make it executable. Then I can, if I pass in the device, which is the same we used before, tty_acm0, and then just say I want it to load up this test.py. It allows me to run and run the script. The script is not stored on the device, but it is easier. So if I make a change, then you can run this command again, and it'll rerun. Yes, and one thing I forgot to mention, that it does have one dependency that this tool needs, which is PySerial. So you can pip install that, or use your package manager to install that. Now I've also written another file. This is a similar thing, but it just cycles through all the colors. It takes about a couple of seconds to boot up, and it also prints out this howdy message. So to store that on the device, and I should also point out that there's a page in the MicroPython docs that talks about all the different commands this tool has, and so that's kind of like the one we just did. We ran a script, and you can access the file system on the device, and if your file is named main.py, then MicroPython on boot up will run this script. So we'll do this, we'll just run that. So we need to use the -f flag, and we'll copy main.py from our file system to its file system. So you can leave out the name, and it'll name the same thing on the board side. And yeah, now that should run that. So that's the new boot up sequence. So next thing I'll show you in the terminal again in Minicom, what happens now when we boot up. Right, so if we run that same previous command, give it a second, connect device, reboot. Now it goes through a cycle, and now we see the howdy come up. So that's all I want to demonstrate for now. Basically connecting up the board, getting it to blink an LED, show an LED using the interpreter, how to load a script on, and then how to permanently add a main.py script. Hopefully, if this video gets some traction, I'll do a few more on interacting with the screen. Hope you enjoyed that, and hopefully it's useful to someone. Bye bye.